Now, why is this all important? When you build these systems, you have intelligence in the computer and then eventually human-level intelligence. Some people think it's within 3 to 4 years. Then after that, you have something called superintelligence. And superintelligence is the intelligence that's higher than of humans. We believe, as an industry, that this could occur within a decade. It is crucial that America get there first. What is China doing? They're leading in something called open source. They are very close behind us. You all have done a great job in doing chip restrictions and things like that to try to slow them down. They're clever and they're smart. They have industrial programs, huge grants going into these companies, and they're weaponizing up in the sense of competition. If you look at DeepSeek showed up, right? Nobody expected this. It turns out it's on par now with some of the top models. Welcome. China has arrived into the competition. What would happen if China beat us? Let's think about it. The path to intelligence, that's superhuman intelligence, think of the national security implications of that competition. This is why I believe, and I'll say directly to you, that although everyone is concerned about Taiwan, I'm much more concerned about this. Because if they come to superintelligence, the strong form of intelligence first, it changes the balance of power globally in ways that we have no way of understanding, predicting, or dealing with. Thank you, Mr. Chairman.
A race between two superpowers, the United States and China. And according to Eric Schmidt, former CEO of Google, this race is not some distant theoretical event. It's already happening, right now, quietly, relentlessly, and the stakes couldn't be higher. You see, we're not just talking about faster algorithms or better recommendation engines. We're talking about artificial intelligence evolving into polymathic engines, systems capable of breakthroughs across fields as diverse as quantum mechanics, drug discovery, and material science, all at a pace and scale far beyond human capacity. This isn't science fiction. This is the world we're entering. And today, on AI Ascension, we're going to unpack why Eric Schmidt believes that winning the AI race could define whether democracy or authoritarianism shapes the global future of intelligence. Eric Schmidt describes AI's emerging role not just as a tool, but as a collaborator with humanity's greatest minds. Imagine having a co-pilot who can test every possible permutation of a scientific theory overnight, simulate quantum effects that used to require years of supercomputer time, or model biological systems, so complex they would overwhelm entire research institutes. Consider AlphaFold, a deep learning model developed by DeepMind that cracked the protein folding problem, a scientific challenge unsolved for 50 years. AlphaFold didn't just predict shapes, it rendered entire folding pathways using attention-based neural networks originally adapted from NLP architectures. The implications for drug development, synthetic biology, and pandemic response. Absolutely transformational. And this is just the beginning. Today's diffusion models and graph neural networks are mapping chemical space, predicting new alloys that could withstand extreme environments, and designing energy materials critical for decarbonization, all before a single real-world test is run. If you're wondering, how fast will this scale? Well, Schmidt suggests that in fields like chemistry, material science, and genomics, AI will soon not just assist, it will lead. But as always, with new tools come new dangers, and this is where Schmidt's warning turns urgent. He identifies two existential risks that are no longer hypothetical: cyber attacks and synthetic biology. In cybersecurity, generative AI is enabling polymorphic malware that mutates code structures dynamically, evades heuristic defenses, and self-optimizes attack vectors. Tools like WormGPT and fraud-targeting LLMs aren't just proof of concepts anymore. They're being sold on dark web marketplaces right now. Meanwhile, in bioengineering, the threat runs even deeper. Language models trained on genomic and proteomic data can now propose novel viral sequences with theoretically enhanced pathogenicity, something we only dreamed of a decade ago. Without robust verification protocols, AI could inadvertently or deliberately aid in designing pathogens faster than our regulatory systems can respond. Schmidt's frustration is clear. China's cyber operations against U.S. infrastructure have been aggressive for years. And the global response? Mostly diplomatic wrist slaps. Now imagine those same cyber capabilities, turbocharged by next-gen AI tooling. 2 years ago, America's lead in generative AI seemed insurmountable. OpenAI's GPT-3 and Google's Palm were peerless. Today? Schmidt says China's leading labs, Baidu's Ernie, Tencent's Hunyuan, Alibaba's Tongyi Qianwen, have released models roughly equivalent to GPT-4's capabilities. And they didn't need 10 years to catch up. They did it in less than 2. How? It comes down to structural advantages, centralized command economy, no regulatory bottlenecks, and a culture of hyper-adoption inside private industry. When the Chinese government wants every logistics company or hospital group to deploy AI, it happens. Not in 5 years, but in months. And despite US export bans on NVIDIA A100s and H100s, Chinese engineers have innovated around hardware limitations, optimizing for inference efficiency with quantized models, pruning strategies, and even multimodal architectures that demand lower flops per task. For tech insiders watching model scaling laws, it's a sobering reminder: creativity isn't monopolized by Silicon Valley. Of course, no conversation about AI's trajectory can ignore compute. Most high-end AI chips, whether it's NVIDIA's H100s, AMD's MI300X, or even Google's TPU v5p, depend on TSMC's 3nm or 5nm fabrication nodes in Taiwan. But Schmidt points out that the US-China conflict isn't just about the chips themselves. It's about the entire stack: rare earth metals, substrate materials, interposers, photolithography equipment. Right now, US sanctions aim to block China's access to extreme ultraviolet EUV lithography machines from ASML. But China's domestic fabs, SMIC, are clawing forward anyway, achieving partial 7nm production yields using DUV multi-patterning tricks, a technological feat once considered improbable. If the bottleneck breaks, and many engineers believe it eventually will, China's AI infrastructure could scale dramatically faster than Washington policymakers expect. Now here's the philosophical core of Schmidt's argument. Speed favors autocracies, but resilience favors democracies. China's centralization lets it build fast, but democracies, through messy collaboration between governments, universities, and private innovators, historically outlast and outperform. Schmidt believes America's advantage lies in its decentralized creativity, the same ecosystem that gave birth to ARPANET, the commercial internet, and the LLM revolution itself. But that advantage is eroding. We face energy bottlenecks that could stall AI training capacity by 2028. We're underfunding STEM education just as AI native fields emerge. And worst of all, our immigration policies are kicking out the very talent. PhDs in machine learning, robotics, computational biology that we desperately need to win this race. Ask yourself, what happens when the best AI engineers trained at MIT, Stanford, and Carnegie Mellon can't get visas to stay? Schmidt's answer is blunt: we lose. This isn't about paranoia, it's about reality. AI is no longer an isolated technology sector. It's becoming the backbone of everything: healthcare, defense, climate science, finance, even governance itself. And the race to master it? It's existential. Eric Schmidt's final warning echoes: if the United States doesn't invest, reform, and accelerate, China will define the future architecture of intelligence, a future where open inquiry, human dignity, and freedom of thought may not be default settings. They may be optional. That's the choice before us. So if you care about innovation, freedom, or simply the ability to define our own destiny, this isn't someone else's fight. It's ours, and it's happening now. This is AI Ascension. If you believe this conversation matters, don't just listen. Act. Share this video. Comment your thoughts below. Are we moving fast enough? Are we thinking big enough? What role should you play in shaping the AI future? Because ready or not, the future of intelligence is racing toward us. Let's make sure it's one worth living in.